Alright, last time I tried this new approach for the gearbox, which would have enabled me to stack little panels and thus change the gear ratio however I needed. However, while this worked probably very well in theory, when putting it out, there's some tolerance issues, and the parts didn't quite fit together as planned. Even trying to turn the gears by hand, very hard, so the poor motor didn't stand a chance to actually operate this in any reliable way at all. So I went back to my original idea, which was simply to add some extra material around the shafts there, this way preventing them from shifting or wobbling during operation. Also adding an extra support that will be press fitted into place, and also a much larger shaft to hold the wheel and its gear, as the tiny 3mm ones will probably snap off during operation. So, let's get it printed out. Oh wait, there's an issue with the gears here. The top is not too bad, but at the bottom there's a sort of bleeding of the edge, which makes it so the extra material at the bottom prevents them from meshing completely, so that might be responsible for a bit of the wobble and issues we've been encountering. Fortunately, this is pretty easy to fix. All you gotta do is get the Dremel and scrape off all that extra material until the teeth are able to mesh properly. Followed with a tiny bit of sanding to remove all that gunk. And since there's also some extra material in the middle there, gotta poke a little hole through so the shaft can rotate nicely. Press drill will be better suited for this, but when in Rome. Now let's clear out that hole. And if you compare it to an intact gear, you can see that ugly border is all gone, and they can properly mesh right now. To avoid this level of post-processing, I could try adding a bevel around the edge of the gear, but for now, this will work. They all slide down relatively easily, and once snapped into place, rotation is pretty easy without any fiddling, unlike our previous model. Testing out of the cogs now. And adding the wheel. Now, sometimes the gears do get stuck, and you have to push them with a bit more force, but in general it's a lot smoother than our previous attempt. Adding the little support, I realized there was a small issue. Since this part is press fitted, once you screw it on, there's no real way to remove it without damaging the shafts and the gearbox. So I'll have to do a minor revision to allow us access to the screws, otherwise the only disassembly method will be using a hammer. The support on that last gear there is also a bit thin, so it's got a bit more play than the others. But in general, that's because when putting the final wheel there wasn't a lot of play for that support, as the gears do have to mesh with one another. Alright, well, enough chit-chat. Let's put the motor on our high-tech support and see if it'll actually be able to turn the gears this time. At least without half an hour of poking and prodding. And... oh! I didn't even have to nudge it this time, as it just started off as my finger approached the gear. Let's try a little speed ramp, as that was another weakness of the previous one. It could only turn at about 98% or higher. Now, sometimes the gears do get stuck. Maybe it's because of the play or the actual design of them. I'll figure that out next time. So, ramping up now. Let's try. Oh, there you go. This is about at 70%, and it's turning. And it's going to slowly ramp up. Faster and faster. Can count the RPMs. It's not really very high, but keep in mind this is a 256 to 1 gearbox, so the motor shaft is turning at about 10,000 RPM right now. Well, that's it for today. We got the basics working, so let's try and fix up the little flaws next time. We'll see if we can get the gears to stop getting stuck, and see if we can redesign it so that support there can be removed without destroying the whole gearbox. But until then, I'll see you next time.